Welcome to MSPTDA video number 21. Yes, Microsoft Power Tools for data analysis. And in this video, we got to talk about Power Query for data modeling. And what we want to look at in this video is how to reduce data model size. Now, all the transformations we're going to make in Excel can equally work in Power BI Desktop. Now, our goal is to take one single very large CSV file from a government website based on Seattle 911 call data and create a call type pivot table where we can slice by the police precinct, the sector, and even down to the beat. There's our counts by the top 20 categories. There's the percentage change between 2017 and 18. With data modeling transformations, we're going to be able to go from a CSV file that's 706 megabytes. If we import the full file, we'd be at 183. But with smart data modeling and an understanding of how the data is stored in the Columnar database, we can get it all the way down to about 3 megabytes. As we've studied in this class so far, because the Columnar database stores each column in a table as a unique list, one of the best ways to reduce file size is to take a column with many different unique values and reduce the count. Now, one way to do that is with rounding a number. We saw that earlier in the class. Another way is if you have date times in a single column, you can break those apart into just the size you need. That's what we'll do in this video. Well, that's one of the things we'll do in this video. We'll actually start the video out by going to a government website, downloading a huge CSV file. We'll also scrape some important data about the columns in that particular data set from a website. Then we'll reduce the cardinality of the columns. That just means going from a large, unique list to a much smaller unique list of items, if that's possible. And we'll do that with the Add Column feature, also with the Transform Columns feature. Other ways to help reduce the size of the Columnar database and the data model is, of course, to remove columns altogether and filter rows. And then once we're done with the data modeling, in this video, we'll create a simple measure. We'll also see how to use Show Values As in a data model pivot table. That's a feature we normally use in a standard pivot table, but we'll use it in our data model pivot table with our measure, and then we'll create that dashboard. Now, in the PDF notes that you can download for this video, I have actually copied and pasted from earlier PDF notes a bunch of terms and definitions of the things we encounter when we're data modeling. Things like grain, fact table, dimension table. Now, the one section we want to go take a brief look at is data models. Now, this is actually just copied and pasted from video number 2 in this class. But requirements for a good data model. The data model must contain the necessary data for the end user. In fact, in the next couple videos, we will get data, and the numbers we actually need are not even in the data source. We'll have to create them. Good data models are easy for the decision maker to use. That's the reporting end of it, where they can simply click on a slicer or click on a visualization or view it on any device. Good data models, of course, allow fast queries. That means when we change a condition in our report or visualization, it reacts quickly. We've talked a bunch about that throughout this class. A good data model is easy to update when new data is available. I think every example we've done so far in the class illustrates that one. And of course, a good data model is easy to update structurally if needed. One of the amazing things about Power Query is even if we have made all sorts of reports and visualizations, if we need to go fix something, we just go back to Power Query, fix it, and when we refresh, everything updates. We've actually seen that a few times in this class so far. On page 9, some of the things we'll see in this video here for reducing the file size and what gets stored in the Columnar database. We only want to import tables that you need. We've seen that a bunch, like when we only selected certain tables from an Excel workbook or an SQL database. Only import columns that you need. Only import rows that you need. And this number 4 right here, this is the most important point in reducing file size. Since the Columnar database stores individual columns as unique lists, reducing the cardinality of the columns by rounding the numbers or breaking columns apart like date-time columns can help to reduce the database size. And as we saw back in video number 14, DAX calculated columns are not stored as efficiently as raw data columns. So if we can push any of the calculations back to the data source like an SQL database, or even in the data modeling phase in Power Query, we want to try and do that. Actually, a couple videos ahead will do exactly that. So these PDF notes, almost all of it review. At the end of the PDF notes, there's some screenshots from this video. Now, we all know how to use Google to search for things. But even a few years ago, if I typed in Seattle data, it might be hard to actually find good data sets from the government. And there are lots of great data portals like this website that we'll go to in just a second. But you can search for cities and agencies. And it's amazing. This is another great data portal where we can have access to and download lots of data. Let's go to this one, City of Seattle. Lots of different areas we can download data from. We're going to go to public safety, road weather, crime data, all sorts of data sets. The one we want is call data. Now it gives you a description here. We're going to use this export button. And look at this down here. Here are all the columns in the data sets, including the description for each. Let's go back up to export. I'm going to click export and then CSV to Excel. Now I'm going to select a location, and this is a big file, so it will take a while. Let's click save. We've downloaded this file, 712 megabytes. Now over here in the start file, our first step is to go data, get and transform from text. We navigate to wherever our folder is. There's our file. Double click. We want to make sure in this step that we have the correct delimiter. It's a comma. We click transform data or edit. Do not click load. Transform data. It promoted headers and changed the type. I'm going to get rid of change type. And guess what? We're going to load this to the data model. This is the entire table with 3.9 million rows. This column here is the unique identifier. So remember, from the point of view of the Columnar database, this column will have to be stored. And there are a few duplicates here, but about 3 million rows in this single column. If we scroll over, there's lots of columns we don't need. The only columns we need is final call type, this column with date and time, and then precinct, sector, and beat. In addition, this column here, we're going to end up filtering it because we only want 2017 and 18 data. So let's just save this or load this to the Columnar database. Close and load to. Add this to the data model, which is our Columnar database. As a connection only, click OK. It's loading. The Columnar database is working, extracting each one of the columns, storing it as a unique list. Now it's loaded. We need to Control S. And there we go. This time it was 215 megabytes. That's the entire CSV file, all the columns, all the rows, stored in the Columnar database. So now we want to go and do data modeling to get just the data we want so that we don't have to load this entire database into RAM when we open the file. Double-click our query. Now the first thing let's try is let's keep all the columns, and we want to filter using text filters. Wait a second. We actually need to have this as a date time. So we're going to change the data type. Remember, we removed that step. We'll change it to date time. Now when we go to the drop down, now we see date time filters. And we want between is after or equal to 1/1/2017. Is before or equal to 12/31/2018. When I click OK, it adds a filter row step. By the way, up in the formula bar, we can see table.selectedRows. And one of the conditions for this column is greater than or equal to the lower limit, if we expand, and the same column less than or equal to the upper limit. Now, pound.datetime is how we get a date value into a formula. There is also a pound time, which we'll use later in this video. Now, when we close and load, it will build a new columnar database based on the columns and rows we have in the data set. Click. It's working. It's rebuilding each one of the columns as a unique list, but only for the dates we specified. There it is, 858,000. Control S. Wow, look at that, 43,000 megabytes. Down over 150 megabytes just by filtering for the rows we need. The next step is let's remove all columns we don't need. Final call type. Hold Shift, click on Original Time Queued. Hold Control, Precinct, Sector, Beat. Any one of these, right-click, remove other columns. Now, this step is going to get rid of all of the columns in our columnar database, including that first column that had all those unique values. I'm going to close and load. We still have the same number of rows loaded to the data model, but of course, there are far fewer columns. Control S. And now over here in Windows Explorer, look at that, down to 13 megabytes. Now, we can do much better. Now, if we only needed the date and not the time, we wouldn't break it apart into two columns. But although we're not going to use time in our dashboard, time might be an important filter for counting the number of 911 calls at a particular time. Now, we're going to do this in a two-step process. I'm going to add an extra column to extract the time. Now, there is a time in Add Column, time only, but that'll give me the seconds, and I don't want that. So custom column, we'll name this time. And we need to construct a time from a date time. The perfect function for that is pound, and in lowercase time. This is how we can create a time value. There's 3 arguments, hour, minute, seconds. So we have this column over here that has our time, time.hour. And this Power Query function can look at a date time and extract the hour. Close parentheses. That's the first argument in pound time, comma. Well, just like there's a time hour, there's a time minute, double click, close parentheses, and then comma 0, because we don't want seconds, close parentheses. And that'll work to get our time. Click OK. Now, that will significantly reduce the number of unique items, because whereas we have 2 p.m., 14 minutes, there might be many different seconds. But over here, now this column, when it's stored as a unique list, will store only 2:14 p.m. as a single value. Now, up in the formula bar, we have table.addColumn. We have our time there. We can come to the very end, and in the last argument of table.addColumn, I can comma, type time, and enter. And that will add our data type time. We could have added a separate step, but we added it right in table.addColumns. Now, the time column was used adding add column. And I want you to notice there are many similar features like date and time, from number. But all of these features will add an extra column. Over on transform, we have similar options. So if I select this column right here, if I selected time only, it would convert the column or transform the column. Now, we don't need to add an extra column, so we are going to transform this one, but we're going to use date. And now we're going to say date only. And there we have our date only. It even added type date. We also want to notice that transform, when we use the options here, adds table.transform columns, whereas over on add custom, when we use something over on add column, it used table.add columns. Now, I'm going to move this by simply clicking and dragging. Double click, I'm going to rename this date and enter. Double click, 911 call type. Now, what we've done is we took that combined date and time column with many unique values, broke it apart into a column with just date and time. Each one of these 2 columns have many fewer unique items. So when we close and load, it's rebuilding those columns in the Columnar database. Still the same number of rows. Control S. Wow, look at that. 3 megabytes. So a little smart data modeling and understanding unique items in columns for the Columnar database can go a long way to reducing the file size and the size of the Columnar database and the data model itself that's loaded in RAM anytime we open up this file. Now, before we build our dashboard, I want to do one last step. I'm going to double-click the query. And what I'd like to do is convert time with hours and seconds to just hours, because any analysis I do, I'm not going to do it down to the minute. Over to Applied Steps, select Add Custom. I'm going to edit it up in the formula bar, click the drop-down. And guess what? After each, that means for each row we had to do a particular formula or function, I had time. All I really want is time hour. So very carefully, backspace. Very carefully, delete. Now type time, that is not what I want. And I don't want type number either, because that would give me decimal. Now type number, time, date. That's how we enter a data type for table.add_columns. For an integer, it's something completely different. Int 64 dot and then capital type. That's the correct data type inside of table.add_columns. When I hit enter, it will change the data type from time to whole number. But wait a second, I don't want it named time, so I'm going to double click and call this column hour. Now I can hit enter. Now we have what we want. Now when we changed it to hour, and anytime you change a step in the middle of applied steps, you got to worry about what is going to happen later. Extract date, well, that worked. Reordered columns, well, it's polite. It says I didn't find the column time. So I'm simply going to come up, double click time, and type hour and enter. Rename columns works just fine. Now when I close and load, it will rebuild that one column in the Columnar database. Close and load. Now still the same number of rows, but now we have 24 unique items instead of 24 times 60 possible minutes, which I think is 1,440. Control S. Wow, it did make a big difference. So we're down to 2 megabytes. Now we still need to add a date table. So I'm going to go over to Manage Data Model. And in Excel, when we have a date column like this, we can simply go up to Design, over to Date Table, and New. Now, the Columnar database has a new table with lots of columns. And these DAX calculated columns take up more memory than if we got this date table from the original source. However, this is a dimension table with not many rows. And guess what? The year column only has 2 unique items, month number 12 and month 12 also. So when we save this to the data model, it will take up very little space. Now, we don't want the last few columns, so I'm going to click on month, year, hold shift, click on day of the week, right click, delete columns. Yes. Control S. If we go over and look, it didn't change it much at all. Back over to the data model, I'm actually going to rename this calendar table to D, date, and enter. Over to diagram view. Right click, delete that date, remove from hierarchy. There's date. I'm going to drag it over to the dimension table. There we have a one-to-many relationship. Control S, data view. On call data, we are going to have one measure. So in one of these columns, I'm going to click in the measure grid. Count calls, colon, equal sign, and we're going to count the rows in the call data table. Close parentheses. That way, whenever we drop something into the row area of the pivot table, the table will be filtered, and count rows will tell us how many rows in this table match that condition in the row area. Enter. Add some number formatting. Alt-Tab. Go back over to Excel, and we can start our pivot table. Insert pivot table, or use the keyboard Alt-N-V. It knows, because it started in an empty cell, that we have something in the data model, so I click OK. Right-click Call Data, Show in Active. Right-click, Show in Active. Active. 911 call data. I'm going to drag that down to the rows. There's like 400 different categories for 911 call types. From our date table, we want to drag year from more fields down to the columns. Oh, look at that. I have some hidden columns. So I'm going to click on A all the way to J. Right-click, Unhide. we actually will hide those columns later. There's our 2018. There's our measure for count calls down to values. Now, this is a big pivot table, and maybe we want to look at all of it. But what we really want to do in our analysis is look at the top 20 sorted. So from the drop down, this is cool in a pivot table. We have label filters. We want value filters. We want top 10, and then change 10 to 20. Tab. OK. Then from the drop down, we want to say more sort options. Down to descending, I want the biggest one on top based on the measure. Look at this. We're in a standard pivot table using these standard pivot table features, but it's working on that measure. Click OK. Now, we could create a measure to calculate the difference, but that measure would be pretty complicated. And since this is a pivot table in Excel, we can mix and match our measure and show values as. That, of course, is this amazing feature with all sorts of built-in calculations in a pivot table. Now, we need to drag count calls down again to values. And that's kind of annoying. Everything says count calls. Let's change the calculation, then we'll come back and change that in just a moment. In this column right here, or whichever one of these two count calls to, right-click, show values as, and we want % difference from. We're doing it from year to year. Previous is what I want. Click OK. Now let's come up and try and change the name here. And when I hit change, it changes them all. But if we come over to the actual measure and type 911 call count and enter, now we get the measure getting its own name and the show values as getting its own name also. Now I want to hide this column, so right-click hide. And I'm going to hide G also. Right-click hide. Now the sort top 20 went away. I should have waited till the end to do it. So let's do it again. More sort options. And I want to sort by 911 call count. Click OK. And there's the top 20. Now we want to add our slicers. Click in a single cell. Pivot table analyze. Insert slicer. Precinct, sector, and beat. Click OK. We can format these how we'd like. And now look at this. We can say, hey, the precinct north. And there are all of our numbers. Top 20 changed from 2017 to 18. Now let's fix this up. Right-click, slicer settings down at the bottom. And so for each slicer, we'll hide items with no data. Now in the north, I want to look at union. And I can go right down to the particular beat, U2. There are the top 20 911 call types with the change from 17 to 18. Now the last thing we want to do over on the table sheet is I want to download a table that gives us information about the columns from that 911 call data set. We're going to go up to data, get and transform, and there it is, from web. I click the address, Control V, click OK. In this window, we can click connect. Now, anytime we're connecting to a source where there's multiple objects we can import, we see the navigator window. We've seen this in Excel and Access, SQL databases. Now, when we're connecting to a website, you may or may not see tables here. We can click and see a preview. Table 2, that's the table we want. Now I'm going to click Transform Data. Let's name this something like 911 call data column info. It looks like it created some steps for us. It has the column names. The data types are fine. I don't need column 4. Right-click Remove. Now I'm going to close and load 2. As a table, existing sheet. There it is. Click OK. And there we have scraped some data from that website, which may be useful for us. Good information about the columns. All right, that was a little fun at the end making a dashboard. But the main point of this video, using Power Query to go from a huge file with lots of columns, lots of unique items in each particular column, and doing data modeling tricks to get just the data we want and reduce the size of what's stored in the Columnar database. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from Excelisfun, including next video number 22. We'll do more data modeling and we'll build not a date table, but a time table that will help us visualize the downtime for different server computers. All right, we'll see you next video.